This video is going to cover scale validation and some of the biases you might run into with scales. I have a video giving an overview of scales. When I'm talking about that, I basically am talking about surveys that have questions involved. They're often used to measure some latent construct, like there might be a scale where you're trying to determine if someone's depressed or not. The reason a scale is useful for that is because it's hard to just ask in a single question, how depressed are you, 0 to 10. It's easier to look at the various facets of this latent construct like depression, separating it to its individual symptoms and asking about that to get a better sense. And basically there's lots of ways to validate a scale. You can look at things like reliability, internal consistency, face validity, criterion validity, and construct validity. Those are all things that I'm going to talk about today. Something I don't know is as far as the actual definition of a validated scale. I'm not certain there's one out there. I think that any of these or any combination of these might contribute to you being able to say your scale has been validated. So one of the common ones is test, retest reliability. And what you do there is you take your final survey or scale and have a group of maybe 100 people take it on one day, and then ask them to take it on another day, and then see how much their answers are correlated first time and the other time. Ideally, there should be perfect agreement. Something you got to consider is some certain traits or questions might be very time dependent. Like if you're asking something about diet today or something about emotion today, it's possible that someone's answers might differ week to week or something like that, depending on if you're administering the survey on 1 week and then another week. It's possible that there might be disagreement, not because there's a problem with the scale, but because that trait has variability over time. There's a measure of internal consistency that kind of quantifies that, which is Cronbach's alpha. There's also face validity, which is basically when you bring in an expert, if the running thing I'm using is depression, if you bring in some expert on depression and they look at the scale and make they determine basically how effective they expect this scale to be, that counts as face validity. Criterion validity is comparing the results of your questionnaire to some kind of gold standard. An example of that is an existing scale. So if there's a scale that is the gold standard for measuring depression, and you have a group of people take that and then take your survey, which might be some abbreviated version or a different version, and ideally everyone that the gold standard says is depressed, your scale will also determine as depressed, and that's the way you can quantify your agreement with a gold standard. And in the case of a questionnaire that's asking about a concussion or a stroke, maybe you can compare the results of your questionnaire to a what's it called, a MRI, and the MRI is going to be a definite answer, but your scale might be able to give an approximate answer, which might be much less expensive. And basically, once you have this, the results of yours and a gold standard, then you get to use things like sensitivity and specificity and really, bring those really quantifiable validity criteria to your scale. Construct validity is an interesting one and a little abstract to explain, but I'll do my best. So here we have this depression score, which is 10, and it is basically this latent construct that is composed of these individual things, all these symptoms of depression, like feelings of self-isolation, loss of interest, feeling tired, and trouble sleeping. Basically each of those are more measurable. You can ask 0 to 10 how much they experience that, and then use that to get a depression score. With construct validity, there's two ways to go about it. There's convergent validity. So basically with that, you take some other scale that also is trying to measure depression, but has very little or none of the same components. You'll see that the middle one, our scale, has these various components of depression like isolation, trouble sleeping, and this other one also is trying to measure depression but has none of the same items. It has none of the same questions. If people take both your test and this other one, that is trying to measure depression, they come to similar conclusions. That's an example of convergent construct validity. And another one is discriminant construct validity, where this other score here, its intent is to measure insomnia, and it's not trying to measure depression. And those things are kind of entangled. They share some similar items. So when you're trying to measure discriminant construct validity, you're trying to find a scale that shares similar items. You'll see that the middle one and the right one both share trouble sleeping and feeling tired, the blue one and the orange one. But what we're hoping here is that basically there's going to be some agreement, but we're hoping if we have like 100 people who take both our middle depression score and the right insomnia score, if there's perfect agreement between the two, then that's an indication that your construct here, your survey is measuring insomnia more than it's measuring depression necessarily. There's going to be some agreement because these two conditions share some symptoms, depression and insomnia. But basically we're hoping that they're going to disagree to some extent, because not everyone who is depressed has insomnia, not everyone with insomnia is depressed necessarily. So for convergent validity, we want our scale to agree with the one on the left, and with discriminant validity, we want our scale to disagree to some extent with the one on the right. Whenever someone says they used a validated scale, unfortunately, there's no real... there's no like actual criteria for what someone has to prove they've done to say their scale is validated. I think it can be really any of those, like that we've talked about today. But yeah, we're going to talk about biases now. So basically, if someone has a valid scale and they alter it in some way by like adding or removing questions or using it on some population that they haven't, that wasn't the population they used to validate it, or if it's just been decades and decades since they developed the scale, all of those things can invalidate the scale. Because when a scale is validated, it's been validated with a very specific combination of questions. It's meant to be used on a specific population, and the cultural understanding of these questions, and it might change over time basically, and all of a sudden your scale is invalidated. The number of scale points can be an issue. This is a Likert type scale here, going from like strongly disagree to strongly agree. Whenever you have a neutral option, basically it presents an opportunity for people to choose it more. Basically, as soon as you have neutral, it's possible that people might just pick that most of the time. Another issue when you get rid of the neutral, it kind of presents this other issue of these points not necessarily being equidistant, and that helps to look at it with stairs. So here, like, the jump from strongly agree to neutral and so on are kind of equal steps, but if you remove the neutral option, then you have this situation where the jump from strongly agree to agree is smaller than the jump from agree to disagree. Like, I think you would probably understand that, like, the difference between agree and disagree is larger than the difference between agree and strongly agree. And one of the major assumptions of lots of these analyses that would use these as like categorical points, like it basically there's a kind of this understanding that the points are going to be equidistant. If it's like a scale going from 0 to 10, like 0 and 1 are the same distance apart as 1 and 2 and 2 and 3. As soon as that's not the case, analysis becomes very complex, and that's something you might create by deleting that neutral point. An example of what that might look like is, let's just say we have these results where we have like most people are agreeing, like 54 people are agreeing, and there's about the same number of people that are neutral and disagree. But if in the same population we added strongly disagree and strongly agree, something we might see here is just if you look closely, you'll see that the people who disagree, those 22 people on the left, most of them strongly disagree. So those who said disagree, they feel strongly. But among the 54 people who agree, most people said agree and not strongly agree. So that sounds kind of weird, but basically what we found out here by adding the additional subtle levels of agreement and disagreement is that people who agree are kind of ambivalent. They don't agree that much. but the people who disagree feel very strongly. And basically, that's a difference that scale on the left wasn't able to detect. Cross-cultural validity is an interesting one where this is something you might see if you go to the hospital, where it's like a visual analog scale where to say the level of pain you're experiencing, you might not be able to read those words above the faces, and you might not be able to count if you're like a really young child. But if you use these faces, then all of a sudden you're able to get a really like kind of easy measurement of how much pain someone's experiencing. And this is an example of a scale that has really high cross-cultural validity. Like you can use it in most countries, and most people are able to make sense of it if they understand the context is pain. Something you got to consider is certain types of scales have less of an understanding and less of a basically cultural meaningfulness in certain locations. For example, the Likert scale has poor validity in certain cultures where all of a sudden the subtle differences between like always, sometimes, and often might not necessarily have the same meaning in certain countries. And all of a sudden it might be better to represent those with numbers or with some other phrase that is more culturally appropriate, basically. And yeah, standardized testing is another one where like that it's kind of like a famous example where things like the SAT or the MCAT are kind of culturally dependent, and like they're getting at core principles of intelligence and stuff like that, but basically there are certain questions where it's not a matter of your understanding of the topic at hand, but it's more just the cultural context of the question make it hard to answer for people who aren't from that country. And yeah, that's something you gotta watch out for. Slider scales are another one that is kind of interesting. I liked this one. This was cool. For example, you'll see the slider scale is one you might see where you get to pick one of these 3 points by sliding the scale to the middle or to the far right, or you might be able to pick like any point on that scale. Basically, it needs to start somewhere. Like when someone has not answered the question yet, it might start at the far left. And if someone skips that question or misses it, if the slider is at the far left, and that means like strong agreement or strong disagreement, then the person's skipped question, this question they didn't even answer or look at, is going to be measured as that initial value. Like let's just say that top value here where it's to the far left is extreme agreement. That means that instead of this being a dropped question that is not answered, it's going to be measured as extreme agreement, when really that's just where the marker began and it's not actually their opinion.